In this video, we are going to go over the Got It number 1 for lesson 6.4, Solving Systems, part 3. This is in the real world. Okay. Make sure before you watch this video that you please have tried this problem. That way you know whether or not you understand it. Marine biologists studied the lengths of two species of shark for several years. The initial length and growth rate of each species are shown in the table. If the growth rates stay the same, at what age would the spiny dogfish shark and the Greenland shark be the same length? What is that length? All right, well, we know that we're looking for the length, right? The length is changing. So we know that L is your first variable, the length in centimeters. All right, they're asking us about the length. We know that it's changing as the Greenland shark is getting older. There, we know that it's in centimeters. That's how I knew that that was the units. It's shown in the table. All right, then to get our other variable, look at our rate, centimeters per year. So we know that the years are changing, which means that T, time in years, is our other variable, right? Because remember, variables change. And we know that the length and the years are changing. All right, we're talking about the length, so we need to make our equations for the Greenland shark. And the spiny dogfish shark. All right, and they want to know if the growth rates stay the same, at what age would the spiny dogfish shark and Greenland shark be the same length? Meaning, we need to set these, after we get these two equations, we need to set them equal to each other. So for the Greenland shark, the L, the length, it starts at 37 centimeters, right? And then it's 0.75 centimeters per year, so it's plus 0.5 T, because time is in years. Every year, it's growing 0.75 centimeters more. All right, and the spiny dogfish shark, the length starts at 22 centimeters when they start observing the species. And then it adds on 1.5 centimeters every year after that. That's why it's 1.5 T. T is time in years. All right. Since the question is asking when will they be the same length, let's set them equal to each other and solve to see when they're going to be the same length. After how many years? So we have 37 plus 0.5 T, and it equals 22 plus 1.5 T. Okay. Remember, you want to get the variables on one side of the equation and the numbers on the other. I like my variables on the left side. So let's we'll switch it up. We'll bring the variables on the right side this time. That way we don't deal with negative numbers. So we can bring subtract 22 from both sides. And we're left with 15 plus 0.75 T equals 1.5 T. Now, if you brought the numbers on the right side and the variables on the left, we're going to get the same answer in the end anyway. It's just what you prefer. I don't want to deal with negative numbers if I don't have to. So now let's bring 0.75 T. We're subtracting that to bring over the variables. They cancel out. You're left with 15 equals 1.5 minus 0.75 is 0.75 T. All right, catch up on the notes. Okay. Think about how you would What's the last step here? Divide both sides by 0.75. All right. 15 divided by 0.75 is 20. So 20 equals t, meaning in 20 years, the lengths of the sharks will be the same.